Good afternoon, everybody. I gotta tell you, this brings memory from my bar mitzvah. Really impressive room. And speaking of memory, sorry. Don't know if you can see anything, but this is the first UX experience I ever had as a child. This is just the dir command, if you can see it here. And do you guys remember how exciting dir was back in the day? You remember the excitement of putting in a floppy disk and just typing dir and waiting for a split second before you see the list of files? Today, things are different for kids. This is my daughter, and you can learn a lot from that picture. First of all, you can learn that for some age groups, Windows 8 actually makes sense. But my daughter is using the Windows 8 tablet I got at Build 11. And she's been using it from the moment that we've got it. She was 2.5, I'm sorry, even 2 at that point, and she just started using it. I didn't need to show her anything. She showed me how to do stuff on that Windows 8. And she uses it like a pro. She's doing everything. She's a ninja. She's a fruit ninja. Whatever you can do with Windows 8, that kid is doing it for at least 2 years now. And one of the things that is very natural to her is the way that the tiles change. It took her a while to understand that this doesn't happen on my Android phone. She got used to it. But there's a big difference from the way that we are used to consume UI and the way that kids are going to, or the next generation is going to consume it. And I'm actually quite worried that my daughter will never know how to use the command line when she grows up to be a developer. So it's going to happen, believe me. So Windows and desktop devices and tablets is one thing, but one area that is still behind is the web. And I'm a football fan. Any football fans here? Yeah. I'm also quite happy that this is the first place where I'm actually saying that and the people understand what I mean by football. And I have season tickets for almost 10 years now for my team, ever since I started to make decent money, decent living. However, in the past few years, I didn't have a lot of chances to go. Actually, I just went to one game this season. I usually consume my football this way, in a meeting room, late at work. And this is live scores. Anyone uses that? And what happens is basically I need to refresh the page, press F5 all the time just to see what happens. And this is a rare occasion where my team is actually leading. I'm an Hapoel Tel Aviv fan. Actually, anyone here ever heard of Hapoel Tel Aviv? Yeah? Chelsea fans? No? Okay, great. So I'm fine. The web has been behind for a while now. And real-time web is a sort of a holy grail, and it has been ever since we started to have Ajax. We started to try and do more sophisticated things with our web, and we had several steps to do that. So, welcome to SignalRity, and I'm Yaniv Rodenski. I want to tell you a little bit about myself. Already you know quite a bit. I work for a company called Tsela in Israel. I'm a Windows Azure MVP. I'm also an author. Those are my main 2 books, my only 2 books actually. And the last one, Pro Couch-Based Server, I'm very proud of. It's going to come out hopefully in 2 months from now. We're almost done. So if you're interested in that sort of thing, you're very welcome. And today we are going to talk about real-time web. And real-time web has been around for ages now, sort of. It started the moment that we started to have Ajax in our application, and the first thing that we used to do is polling. How many of you do polling in your applications? Okay. What? Okay, so you're doing it through SignalR. And polling has a bad reputation in this world, basically because we are sending a lot of requests. And sending a lot of requests, basically polling means that we are calling the server on an interval to get our data. We all know that. And there's been a science behind that interval. People have all sorts of opinion. How much is too much? How much will affect our server? How much is too slow? When can we detect the delay? And one thing I want you to think about polling, that polling has a bad reputation because of all the requests that we are sending. But actually, there's one thing you should consider about polling that might make it less bad. In HTTP 1.1, we started to have persistent connection. Anyone knows what that means? Okay. So in HTTP 1.1, you started to have the capability to send a header called connection, and you have the option to send a value of keep alive. And what that means is that the HTTP request insinuates to the infrastructure, I'm going to send another message pretty soon. So if you can keep that underlying connection open, please do that. It doesn't guarantee that. First of all, HTTP doesn't know if it runs on top of a transport protocol that can maintain that connection. And even if it does run on TCP, which is 99.99% of the time, it doesn't always supported by the infrastructure, as you said. Sometimes the infrastructure forces us to close the connection. But if we can maintain that, polling is not as heavy as we suspected because we are maintaining a continuous TCP connection. And there's also a balance here, and I can talk about that for ages, but you're not here to listen to me talk about HTTP, which I love. The next step that we've got is a whole family based on HTTP capabilities, called chunk transfer. And chunk transfer basically means that we can send one request and continuously get responses. So you might know that as long polling. Anyone uses long polling here? No? Okay, so long polling basically means that we're sending a request to the server and the response is being sent to us continuously. And this is something that is also built into HTTP 1.1. So we are able to save on the requests that we are sending, but still, the moment that something happens, the moment that communication breaks, we need to send another request and continuously get a response. On top of that, we have a few techniques that evolved. First of all, forever frame for IE. And forever frame basically means that we have a hidden frame somewhere that continuously gets an empty script tags until it has something to do, and then it sends a script tag with actually some script in it that does stuff. Next step is server-sent events. Server-sent event is an HTML5 API, and it basically just gives you an event-based semantic for chunk transfer. So you're registering to an event. Underneath, HTTP does the same. You're sending a request and continuously getting a response. And HTTP carried us a long way in the age of real-time web, and it is a powerful protocol, but eventually we need something better than that, and that thing is WebSockets. And WebSockets actually let us open a socket over HTTP communication and have a real bidirectional communication between a client and a server. So let's take a look at WebSockets and what we can do with them. Okay. So for WebSockets, I'm going to use a NuGet package, if NuGet will work for me. And this is called Microsoft WebSockets. Let's try again. Let's try from this actually have it installed. Microsoft WebSockets. So this package allows me to communicate using WebSockets. I'm just gonna use this. And what I have here is an API controller. This is just, sorry. Okay, so this is just a web API action, a GET action, and inside of it, I'm using the HTTP context, accept WebSocket request, and I'm passing along something called my WebSockets handler. This is a class that I've implemented, which is deriving from WebSockets handler. And this class comes from that NuGet package, from that specific API, and it allows me basically to handle WebSocket requests and send back WebSockets messages to the client. So you can see that I have a WebSockets collection here, and I'm just adding this handler to the WebSockets list, and now I can manage those. I can handle the connections to the client, and I can send them some messages. So let's try it. Let me have one page. And let's open another one. Now I can just message myself. And if you can see down there, I'm getting the messages. Let's do it. And this actually works. It's quite simple, not a lot of code, and now I'm able to send WebSocket messages. Am I done? Is it all good? Can I just now publish this application? That's the big question. Are WebSockets good enough for me? Any ideas? It depends on several things. One thing it depends on is my browser. This is not just Internet Explorer, it runs on compatibility mode, and let's try to use it from Explorer. So this emulates, or should emulate, Internet Explorer 9. And it simply doesn't work. So not all browsers support WebSockets. That's one problem. And in a world that is having difficulties saying goodbye to IE6, that's a big issue. We have other issues. So a little bit about WebSockets and the challenges of working with WebSockets. First of all, WebSockets are an HTML5 standard. And that might be a little bit harsh, but it is still not well supported everywhere. We need to remember that HTML5 doesn't still work everywhere. Another thing is that it is a low-level API. And I actually forgot to show you how it looks on the JavaScript side. I'll show you in a moment. But we have strict prerequisites. We need the browser to support this. We need the server to support WebSockets. We need our firewalls and proxies to allow WebSockets. We need to handle things like load balancers. And the internet is a very complicated place when you look at it. Messages don't just go from one point to the other. And for us to introduce a whole new protocol after 25 years of internet, that's going to take some time. that's going to evolve. So this is exactly, sorry, new clicker. So this is exactly the kind of dilemmas the SignalR is trying to solve. And SignalR gives us a higher level of APIs to handle real-time web. And this time we don't need to manage the actual way that we're doing it. We don't need to choose the technique. SignalR allows us to basically just write two-way communication in our code and let SignalR sort out what is the best option for us. That is the big promise of SignalR. And SignalR, probably the most common API of SignalR is the hubs API. And hubs are basically bidirectional services in SignalR. You can think of them as your controllers in your ASP.NET, as your API controllers in your web APIs. That's what hubs are. And hubs allow us to manage the kind of bidirectional communication and invoke methods on the client without knowing how we are getting there. So let's take a look at hubs. And before that, let me just go back and show you the client side for the application that I showed you before. So that was the WebSocket handler on the server. One thing that I didn't show you is my JavaScript code. And this is the most important thing. So first of all, for WebSockets, I'm using this URI to connect to the server using WebSockets. And you can see that this is actually not HTTP. It's a different protocol. WS, that's a scheme for it. And the next thing that I'm adding here is WebSockets. I'm just creating a new WebSocket. And this is actually a part of the HTML5 specification. So on more advanced browsers, I'm going to have that. On IE9, as I showed you, this object doesn't exist. That's the big problem. And now I can use it. I can send, I can receive messages. This is the API. Let's take a look at how it's done with SignalR. So for SignalR, I have a hub. And this is the unit that I'm working with. Let me just increase the font here. Okay, sorry about that. And this is one of the methods that is exposed by the hub. This is actually something that the client can call and just submit something that is called a task. And this is a task management application. I'm going to show you this application in a moment. And it's passing along parameters. This is going to behave like every service that you know and love. And in that service, I'm going to save the task to a database. I'm using Couchbase Server. You probably know by now that I love Couchbase. And then I'm going to use something called client. This is a part of the Hub API. I'm going to use clients all, and I'm going to invoke a method. And what's interesting about the clients, that I don't know if you can see this, is that all is actually of type dynamic. And the reason that it is of type dynamic is that all represents a dynamic language. You can guess by the casing on my method that this is actually calling a JavaScript object. So let's run this application. Okay. So this is a simple task management application. And I'm out of room down here. Let's see if we can see anything. Okay. So I'm arriving at my hub, and this is just a simple HTTP call. And now I'm broadcasting everything to the clients. Let me just free us some room down here. Okay. Let's try this again. Let's do it like this. Okay, so we got it, and now we've disabled all the breakpoints. One last chance. And down here, we got it. Okay, so it's pretty simple, pretty straightforward. But it's not enough. And let's take a look at what actually happened here. So we saw our hub, and the hub is pretty simple, just 4 lines of code. Let's take a look at the client. And the client, basically the JavaScript, I built in Knockout. So first of all, I have a view model, and I have this function. And this function is the submit task. I'm using something called a hub here, .server.submit task. This is how I'm calling my server from my JavaScript. This is how I'm getting it, and it is defined in a script. I'm going to show you in a moment the script, because it is interesting where it comes from. On my document ready, I'm just doing this, the $connection tasks hub and connection start. Now I can call this method and get to the server. On the other hand, I have the hub client. This represents the client for the server, and I'm just adding here a method called the add task. This is exactly the method that we called from the hub. This method is basically a JavaScript method that I added to the client object. And because JavaScript is a dynamic language, I can just do that. I can just add whatever method I want, and I can call it from my hub. Once the hub calls my function, I just push into the tasks array the new task and apply binding. This is just plain Knockout. So the only thing that is missing is where did I get my hub from and what happens in between. So let's take a look. Not here, sorry. Here. And this is my view. And a few things that I want you to notice here. First of all, I'm using jQuery. I'm using jQuery and jQuery UI here, and I'm using jQuery.SignalRy here. And the SignalR client is based on jQuery, so you're going to need jQuery to be defined before it. And this is actually a script file on the file system. There's another SignalR file called hubs here. You can see this script, and if you look for that on the file system, you won't find it. Because this script is actually being created at runtime by SignalR, and basically builds the hub object for you. And this is just something that the hub itself creates for you in runtime, just generates a JavaScript, and that JavaScript has the hub object, so you can call it on one hand, and you can add methods to the client and register. And that's it. We're ready to go. So hubs are very simple and very straightforward. And one thing that hubs will help you with is that they will be able to work with older browsers. So let's take a look at this again. And let me just free some more room at the bottom as well. There are downsides for practicing too much, apparently. Should be okay. So let's take a look again. Okay, we're fine. Let's open Internet Explorer for the same page. And doesn't come up correctly. Let's see if we can get this to work. No. But there is a different issue with my Internet Explorer I can see. Just one last try. Doesn't seem to work. Yes. Yes. But for some reason, there is something even more fundamentally wrong with my Internet Explorer for right now, so let's leave it. But this will work, and the reason it will work is because SignalR negotiate which protocol to use. And this is one of the things that SignalR takes away from us. Because SignalR basically, and we're going to take a look at the SignalR protocols, part of it that I can show you, begins the conversation with negotiating the protocol. Basically says, hi, I have WebSockets in the browser. Server, what do you have? And the server says, I have WebSockets, let's try to connect. But if they can't connect, if something in the middle blocks them for WebSockets, it will start to fall back to other mechanisms. And we're going to take a look at it in a moment. So hubs are very simple, very straightforward, but they have other capabilities. For example, we can send messages to a specific client. We don't need to send everybody everything and let the client sort it out. We can actually send messages to a specific client, and that's a nice thing. Another thing that we have in SignalR is something called groups. Clients can add themselves to a group. Okay, say, I'm interested in this specific subject. I'm interested in Hapoel Tel Aviv games. I'm not interested in Manchester United or AC Milan. So we can create groups and let SignalR manage it for us. And let's take a look at how we can use SignalR to manage groups and connections. And to do that, I have an even better example. So let me just run this one. So, if you know me, you'd probably guess I didn't write this UI, and that's true, because I can't. I'm very bad at writing UI. My wife helped, and the reason that she helped is that she needs some sort of mechanism to manage my tasks. And this is a bigger application, because in this application, I can actually log in. Most of the time. Okay, I think I'm logged in. And now, let me just log in my wife as well. And now, not only we can buy me shoes. Nice ones. Eventually, the demo gods got me. I was just about to say how all my demos went well in DevWeek. Shoes. What's wrong here? Let me just open developer tools, and we can learn from everything. Okay. So let's take a look at this. Okay, there is something wrong here. There's something really wrong here. Let's try something else here. Let's try one more time. Apparently, for some reason, I don't have communication within my box, and that is something that SignalR can't get around. Let me just, possibly, because Fiddler crashed before. One last time. No? Let's take a look if we still have an error. Yes, we do. And my server just died for some reason. So let me just show you my code, because these things kind of happen. happens sometime. And let's take a look at the hub code. So submit task is a little bit heavier right now. And you can see that I have here an if statement. I'm checking if there is a category. And I've introduced the idea of category because sometimes I just want to take care of tasks for home, tasks for work, and I can take a look at them. So in that case, if I do have a category, I'm just going to broadcast the category for a group. This is the name of the category. If not, I'm just going to broadcast it to everyone. And this is, again, another SignalR action or method. And you can see that here I'm not sending a message to anyone. I'm just allowing the client to go to my hub and register to the group. And every time a client executes anything against my server, I can get the connection ID from its context, from the context object. And that means I can identify this client every time. So this is one thing. The other thing is that when I'm dragging a task to the list of my tasks, I'm doing this. I'm calling the take ownership method. And the take ownership method's calling something called others. You can see it here. And basically, this will broadcast the message to everyone except me. Yes? Okay, so it's a good question. So others, yes. Basically, what others does, first of all, you can see that I have a few options here. I have all, I have caller, and I have others. And I can basically take all and just query it. It's an IEnumerable. I can iterate on it. But others is actually compiled, is actually already being traversed for me once. Okay, this is a list that actually was created for me when the hub was instantiated. So this will just send for a specific connection. However, in older versions of SignalR, groups would just add the group information to the message and send it to everyone. Okay, so you need to make sure, and I'm going to talk about the SignalR protocol pretty soon. I'm going to try to make my demo work one more time, but you need to open developer tools or Fiddler or anything and just take a look at the messages. Whether it's WebSockets or long polling, you can, the SignalR protocol is built of, it's basically JSON documents going over the wire, and you can actually check which messages go where. Okay, so some on older versions of SignalR, groups, for example, wasn't a good thing to handle security with, because everybody would get the information, just the client side. The SignalR library wouldn't show it. Okay. So the SignalR protocol, and I'm hoping that I'll be able to show you and not just mime about the protocol, but the SignalR protocol basically has 3 stages. The first one is the negotiation phase. And the negotiation phase is basically what allows SignalR to determine which is the best protocol for you to use. It begins with a client call, and the client call knows what is the highest API it can use because it knows which browser it runs in. So the client starts, let's say, with WebSockets, calls the server. The server runs on Windows 2012. That means that it can support, for example, WebSockets. They'll try to communicate over WebSockets. However, as we said, we might have issues. Our firewall can block those. Our load balancer can interrupt with them. Any number of things can happen. And if they can't communicate, they'll try to communicate, and if they don't get the proper responses in the times that they set, they'll start to negotiate. They'll start to fall back. They'll go back to long polling, okay, and they'll try that. They'll fall back to forever frames. Actually, they won't fall back all the way to polling. Okay, so forever frames is the lowest as they get. Should be good enough. And if they manage to communicate, the next phase is the connect. Because I called a hub. I try to connect to a hub. I get from the hub back the hub information, the methods that I can call, a description of the hub. This is for the client library. And from that moment on, we can start sending data. This is how the SignalRity protocol works. And there are certain things that you can see. Let's try one last time to run my application and see what we can gather from the SignalRity protocol. So, and let's just I'm suspecting that the problem is with my Visual Studio. Let me just. It works. It's alive. Okay, so let's try to do this before it breaks. So, first of all, let me show you my application, and then we'll take a look at the network tab. So, I'm Yaniv. My wife Maureen, and let's take a look if it continues to work. No. What? Let's try again. Yes. Thank you, sir. Okay. So first of all, what we've seen here, you can see that I'm looking at other people's tasks. That means that I got it through the others call. As long as my wife takes more tasks, I can finish my book on time, and I'm getting the messages. Now let's take a look at SignalRity protocol. Let's do this again. Okay. So, this is the negotiate step. And this is just a call to the hub itself. And let's take a look at the response. First of all, I have a connection token. This connection token is what actually helps us match between the client and the server. This is what the infrastructure uses. However, we also have the connection ID. This is the same ID that we get from the context.connection ID. This is something the server sent back to the client. We have keep alive timeout. So in every protocol, the server is going to send keep alive messages, so the client knows that it is still there. And it's important because we don't want the client to just keep waiting for something that is no longer there. Try WebSockets. Sorry. Try WebSockets. Try WebSocket means this is the server saying, hey, I'm cool with WebSockets. The client says, sent in the URI that it tries WebSockets. Sorry, part of the request. And the server says, yes, I can support WebSockets. And now we can start negotiate. We can start the negotiation phase. And they try to, and they are able to connect. And they are connecting. And if you can take a look here, connect, transport equal WebSockets. That's it. That's it. They managed to use WebSockets. Now the conversation is switching to WebSockets. And in fact, we can take a look at the frames here. And I refreshed, so I don't have any messages, but let's just take a look again. Should have some more frames now. And so this is just a cursor. This is just something to maintain the position inside the conversation. For some reason, I don't see anything else. Let's just add a new task. Let's see if we can get some more information. And this is a message, okay? And what we see here in the JSON document is, and now we will use the magnifier. Okay, so what we see here is the name of the hub. And remember, we need to match the hub as well at the client side. The task, what we're calling, and the data itself. This is how SignalR communicates. And this allows us to do a lot of things because we're just using WebSockets and JSON. Sorry. We are now able to do a lot of things with it. For example, we can consume it. Sorry. We can consume it from different clients. So we have .NET clients for SignalR, and that means you don't necessarily need to be working on a web application to use SignalR for communication. You can use it from any .NET application. You can use it from Windows 8, Windows Phone, Silverlight even, and Xamarin. In fact, because it is a very simple protocol, you can use it from any other language. We have implementation in Objective-C, in C++, we have Java for Android, and we have even an implementation for Node.js. So let's take a look at how we can use the same use clients from other environments. I'm going to show you two clients. And the first client I'm going to show you is a .NET Console application. And let me just show you that it works. So it is connected to the same application. We just add one message. And we got it here. So how can we use this from a .NET application? It's actually quite simple. I have a NuGet package, a library called SignalR.NET Client. And I get a hub connection object here. All I need to do is just connect to my web server and create hub proxy. This is the name of my hub, the tasks hub. I'm starting the connection. Once the connection is started, I'm just writing to the UI that we managed to connect. If there's an error, I can handle it. And next, I can use the on method and pass it a Lambda expression or even a function to handle the server's calls. As simple as that. I even have the invoke method, so I can actually call the server from .NET clients. I don't need just to listen, but it is very simple. .NET is not a dynamic language. I don't know why they didn't maintain consistency between the hub API that actually uses dynamic and the client connection. I think it would be quite nice if we had a dynamic object we can just add method and register to, but this is how they done it. So using from .NET applications is one thing, but I can also use it from Node.js. So let me just open Sublime Text. And this is a Node.js application. And Node.js has also a SignalR client library. Let me just no, that's so I'm using the SignalR client. Any Node.js developers here, by the way? No? So this is pretty simple. I'm just requiring this library. I'm creating a new SignalR client, passing along the server and an array of my hubs. And now I can just register to an event for the hub, for the tasks, and this is the callback. This is what will be called once my client runs. So let me just run this. Just do node. Let me just. So now I'm connected, and once again, I can just use my web application. Let's put it over here. And I can just send messages to my Node.js application. And actually, this is something that one of my clients use in production, because they have an ASP.NET application, which is a legacy application, and they're moving a lot of things into Node.js. And they want to communicate between the two. And it's actually quite easy way for them to communicate between their legacy .NET application and their new Node.js application. And the Node.js application runs on Linux servers, and the ASP.NET runs on Windows, and it just works for them. So this quite simple protocol goes a long way for Node.js, for SignalR. But communicating with clients is one side of the story. There's a problem with real-time applications because both in polling, long polling, and WebSockets, we are dependent on the server. So polling is one problem. But what happens if our servers are behind load balancers and we have a WebSocket connection, and for some reason the client refreshes? How can we maintain this? And SignalR has something called backplan. And backplan actually means that we can add different instances of the same application to some sort of mechanism that synchronizes messages between them. So if I have 2 servers or 10 servers, all for the same application behind a load balancer, I can make sure that no matter which one my client connects to, they will still get the message. So We can use several things for a backplane. We can use SQL Server for a backplane, and basically the nodes will communicate through SQL Server. Redis is an in-memory key value store database that is also used as a pub sub mechanism, and you can use that to scale. And actually on Windows Azure, you can now get Redis as a service from the Windows Azure store. There's a service there. But also on Windows Azure, we can use the Windows Azure service bus to communicate between nodes. So let's do this. Let's try and run this in the cloud. So I'm going to take this application. And I'm going to change it just a little bit around. This is the start class for SignalR. And there are two things here. First of all, the app.map hubs. This is actually just setting up my hubs for ASP.NET. And you must have that before you are using. It's just a bit of boilerplate code. But this is the thing that actually configures the SignalR hubs for you. The other thing that I can do is use this global host and basically tell SignalR to use service bus, and now I'm just giving it a service bus namespace. This is a Windows Azure service bus. Anyone here uses the Windows Azure service bus? Okay, so let me just show you how you set this up. You go to, actually, it's no longer Windows Azure. It is on the outside, but once you go in, it is now the brand new and a little bit slow Microsoft Azure. So they did a big rebranding now. And this is the wrong subscription. Let me just go over here. Okay, so service bus. And what I have here is a namespace. You can just use this plus to create the namespace, give it a name, select a location, and once you have it, you can just click on it and get the access information, and that's the string that I put in my SignalR application, this thing. That's all you need. Another thing that you might need is a website. And I actually created one called DevWeek. So the same application, I just uploaded before to save time. So let's take a look if we can make this work. This is the one on Windows Azure. Let me expand here. This is the one on premises. And let's just try to submit. And you can see that this client is connected to DevWeek on Windows Azure websites, and this one is connected to my local machine, and still, they both get the same messages. One thing you want to make sure if you are running on Windows Azure, on Microsoft Azure, I'm sorry, it will take time. And you want to go into configure and make sure that you have WebSockets on. And as you can see, right now it is off. So I am using long polling. Okay. So we've talked about the client, and we actually got to the end. With all the problems and everything, we got to the end of my presentation. And there are several things I want you to take away from this session. First of all is that real-time web is no longer complicated and doesn't need to be complicated. You actually have solutions in .NET, in other environments, for Node.js, for example, if you are using it or considering, you have Socket.io. SignalR is not just for web development. You can use it to communicate with clients. You can use it for interoperability with other environments, and that is important because it's a good way to transfer messages that needs to be bidirectional. You don't want to just expose services to other languages. And I gotta tell you, the client that I told you about is doing very interesting things with SignalR and other environments just as an integration mechanism. And it works great for them. It can scale, and it is extremely easy to get started with SignalR. You don't need anything. So you can get my demos here. I hope they will work for you. That's my Twitter, because all my talks come with a lifetime warranty. Whatever you want to ask, you can get me on Twitter, and people will see that, so if I don't answer, everybody knows. The SignalR.net website has a lot of useful information, and those couple of Twitter accounts, Damian Edwards and David Fowler, they're developing SignalR, so lots of information comes from there. And that's it for me now, so do you have any questions? No? Thank you very much. Thank you. And real-time web is a sort of a holy grail, and it has been ever since we started to have Ajax. We started to try and do more sophisticated things with our web, and we had several steps to do that. So, welcome to SignalRity, and I'm Yaniv Rodenski. I want to tell you a little bit about myself. Already, you know quite a bit. I work for a company called Tsela in Israel. I'm a Windows Azure MVP. I'm also an author. Those are my main 2 books, my only 2 books actually. And the last one, Pro Couch-Based Server, I'm very proud of. It's going to come out hopefully in 2 months from now. We're almost done. So if you're interested in that sort of thing, you're very welcome. And today we are going to talk about real-time web. And real-time web has been around for ages now, sort of. It started the moment that we started to have Ajax in our application, and the first thing that we used to do is polling. How many of you do polling in your applications? Okay. What? Okay, so you're doing it through SignalR. And polling has a bad reputation in this world, basically because we are sending a lot of requests. And sending a lot of requests, basically polling means that we are waiting, we are calling the server on an interval to get our data. We all know that. And there's been a science behind that interval. People have all sorts of opinion. How much is too much? How much will affect our server? How much is too slow? When can we detect the delay? And one thing I want you to think about polling, that polling has a bad reputation because of all the requests that we are sending. But actually, there's one thing you should consider about polling that might make it less bad. In HTTP 1.1, we started to have persistent connection. Anyone knows what that means? Okay. So in HTTP 1.1, you started to have the capability to send a header called connection, and you have the option to send a value of keep alive. And what that means is that the HTTP request. Good afternoon, everybody. I gotta say, tell you, this brings memory from my bar mitzvah. Really impressive room. And speaking of memory, sorry. Don't know if you can see anything, but this is the first UX experience I ever had as a child. This is just the dir command, if you can see it here. And do you guys remember how exciting dir was back in the day? You remember the excitement of putting in a floppy disk and just typing dir and waiting for a split second before you see the list of files? Today, things are different for kids. This is my daughter, and you can learn a lot from that picture. First of all, you can learn that for some age groups, Windows 8 actually makes sense. But my daughter is using the Windows 8 tablet I got at Build 11. And she's been using it from the moment that we've got it. She was 2.5, I'm sorry, even 2 at that point, and she just started using it. I didn't need to show her anything. She showed me how to do stuff on that Windows 8. And she uses it like a pro. She's doing everything. She's a ninja. She's a fruit ninja. Whatever you can do with Windows 8, that kid is doing it for at least 2 years now. And one of the things that is very natural to her is the way that the tiles change. It took her a while to understand that this doesn't happen on my Android phone. She got used to it. But there's a big difference from the way that we are used to consume UI and the way that kids are going to, or the next generation is going to consume it. And I'm actually quite worried that my daughter will never know how to use the command line when she grows up to be a developer. So it's going to happen, believe me. So Windows and desktop devices and tablets is one thing, but one area that is still behind is the web. And I'm a football fan. Any football fans here? Yeah. I'm also quite happy that this is the first place where I'm actually saying that, and the people understand what I mean by football. And I have season tickets for almost 10 years now for my team, ever since I started to make decent money, decent living. However, in the past few years, I didn't have a lot of chances to go. Actually, I just went to one game this season. I usually consume my football this way, in a meeting room, late at work. And this is live scores. Anyone uses that? And what happens is basically I need to refresh the page, press F5 all the time just to see what happens. And this is a rare occasion where my team is actually leading. I'm an Hapoel Tel Aviv fan. Actually, anyone here ever heard of Hapoel Tel Aviv? Yeah? Chelsea fans? No? Okay, great. So I'm fine. The web has been behind for a while now.